Hello, my name is John McLean. I'm here with my partners Jordan and Ethan from Group 7, and we are going to talk a little bit about our drainage case study. The purpose of this case study is to identify an existing drainage problem on the 18th green at North Golf and Country Club in northern Quebec. Once the problem is identified, there will be three possible solutions for repair put forward for consideration. In this document, the three recommendations will be listed as the least disruptive to the most disruptive with respect to the playability of the golf course. The problem this group has been tasked with is the accumulation of water in low-lying areas on the 18th green, resulting in standing water on the turf surface. The green is a modified USGA spec green. It has been considered to have relatively good drainage in the past. Lab results have conducted a saturated hydraulic conductivity level of 0.5 of an inch per hour. Through research of the problem, we have found that the HC, the hydraulic conductivity of 0.5 per hour, is significantly low. The USGA recommends a HC of 6 inches per hour or higher. In an article written from Chong with the Golf Course Superintendent Association of America, they have stated that hydraulic conductivity is the key to controlling water movement in sand root zone mix. Low hydraulic conductivity of a sand root zone mix results in poor drainage, which leads to a waterlogged green profile. Poor drainage is commonly caused by one or more of the following: soil compaction, incorrect sand particle sizes, accumulation of organic material, or clogging in the soil pores. It is clear that it is crucial to reestablish a strong EC. During research, we have found a constant theme with the problem we are facing, which is the accumulation of organic matter in the soil. Therefore, we have determined that the 18th green has accumulated enough organic matter to reduce the infiltration of water significantly enough to pool on the surface, commonly known as black layer. So what is black layer? Is the formation of this layer can be caused by excessive irrigation precipitation resulting in standing water, the buildup of organic matter, compaction, heavy thatch layers, or sulfur application. These cases promote the buildup of hydrogen sulfide by promoting the growth of sulfur-reducing bacteria. The bacteria survives in soil that are low in air, resulting in anaerobic soil. This can be caused by improper aeration of the soil. Black layer ultimately causes improper drainage on the soil surface. I'm now going to pass you off to Jordan, and he is going to go in a little bit deeper into the details of solution number 1.
Thanks, John. Some possible solutions to consider when managing black layer are some proper uses of cultural practices. So the practice of aeration can limit the number of sulfur-reducing bacteria by reducing compaction and adding drainage to the green. Combine this with the top dressing to fill in the holes, resulting in the breakup of the thatch layer while still ensuring proper drainage. Consistent aeration will not only reduce the black layer, but will also prevent it. On top of these two practices, be sure to carefully monitor the irrigation program in the area to ensure you do not have a buildup of water due to over-irrigating. These practices will result in minimal disturbance to play, as well as they tend to be much less costly when compared to the reconstruction of a green. Assuming proper aeration equipment is available on site, aeration should cost you no more than 30 minutes of labor on the troubled green. If you're using tines the size of 5/8 inches at a depth of 6 inch with a spacing of 1.5 inches by 1.5 inches, your displacement on the green will be approximately 13.64%. The amount of sand required to fill these holes based on this displacement on a 1,000 square foot green would be 818.4 cubic feet. With 1 ton of sand, covering 22 feet cubed, and the cost of sand at $35 per ton, it would cost approximately $1,300 to top dress 1,000 square foot green. Now I'm going to switch it over back to John to talk about the solution number 2.
Thanks, Jordan. So solution number 2 is a medium disturbance, and it's a partial green renovation. So I have a little quote here from Gilholy and Foy from the USGA. With frequent top dressing programs being performed on putting greens, a problem courses across the country encounter on an increased basis is the development of collar ridges or sand dams that restrict surface drainage. This solution will mainly be focusing on providing the green with proper grade and contours to eliminate the low spots where water collects. This project will minimize the disturbance of the green to the smallest portion possible, leaving the green still available for play. Another quote from Gilholy and Foy is, surface drainage is important, if not more important than internal and subsurface drainage. Even with USGA greens that have sand-based root zones and subsurface drainage system, surface depression or low-lying perimeter areas where surface drainage is blocked will experience problems. When water is trapped and concentrated, the upper root zone will remain saturated for extended periods of time, and turf failure will ultimately occur due to anaerobic conditions. Increasing disease, algae, and black layer problems also are commonly experienced on putting greens with poor surface drainage. With this in mind, the low spot of the green where there is water pooling on the surface will be removed by means of regrading the section between the water and the green collar, allowing water to have a path to drain. Using a sod cutter to remove the turf grass before re-encountering occurs will allow the option to reuse the sod. Another one from Gilholy and Foy, there will be cases where collar ridges are so severe that it is necessary to remove sod and regrade the collars and surround areas. It may be necessary to resod with new materials, but the sod can be replaced if it does not have excessive thatch buildup. Once the turf has been removed, the use of a small sand pro machine with a front blade, along with hand tools, can be utilized to reshape the surface, allowing the grade to be lowered, eliminating the possibility for water to be contained on the green. Using the builder's level during this process is vital to ensure 1.5% is the minimum drainage, and that is from Brower at the Golf Course Industry magazine. The cost of this project will be minimal. There are no materials required for purchase if the sod can be removed with care, preventing any damage. The minor construction project could be completed over a span of 1 to 2 days with 2 workers. Once the project has been completed and the low spot of the green has been removed, cultural practices such as aeration and top dressing will be required to maintain healthy turf grass and preventing future black layer buildup. I'm now going to pass you off to Ethan for solution number 3.
Okay, thanks, John. For our third and final solution here, it's going to have the most significant disturbance. The final solution is going to result in the greatest impact on the green, rendering the entire green unplayable during the renovation process. Camara at the USGA cites one of the 5 main reasons for putting green renovation as the organic matter accumulation to a degree that is too difficult to dilute with core aeration and sand top dressing. So with this in mind, a full greens renovation is very labour intensive, with play likely not returning to the green for the following season, as the Gulf window in northern Quebec is approximately only 5 months. With that in consideration and the fact that greens are relatively young at 15 years, a full greens renovation would not be recommended at this time. However, a partial greens renovation in the front left quarter of the green and collar where the pooling has occurred is feasible. Understanding this is a very disruptive process, the solution is looking much more at a long-term investment with immediate removal of the black layer and establishment of newer turf. This green could survive sustainably longer than its current state. The cultural practice would be reduced and overall turf health would be improved to provide a better playing experience by renovating this immediately. Removing removing the soils and recontouring the green to prevent this problem from reoccurring and provide better surface water and subsurface drainage. Improving subsurface drainage and increasing the hydraulic conductivity will result in greater root development, turf health, and turf density, with the outcome being a better putting surface in the end. So the process will be broken down into 3 phases here. So phase 1 will be a removal of the existing turf down to the subgrade. Phase 2 is going to be the recontouring of the subgrade and reinstalling of the drainage system. For this final solution here, we do plan to bring it right down, recontour the subgrade, redo all our drainage, and then re-establish our turf for phase 3. So the first phase is going to be the removal of all the sod in the existing root zone. So the benefit of this renovation method is to remove all the black layer immediately to ensure that it's all removed and we don't have this problem again. Down to approximately 16 inches to the top of the existing subgrade where the drainage tile lies. So phase 2 will reshape and recontour the subgrade to reflect the desired end product here. New 4-inch drainage tile will be installed in case the old tile was compromised in a removal or the previous installation. And then USGA spec soil, sand soil mix will be added, recontoured for better drainage and removal of the low spots. So in phase 3, we'll replace the sod. We'll attempt to reuse the sod that was previously used using the same sand as the first construction. Make sure that the sod is growing in the same medium as the parent material. If not, if that sod is no good, the roots are rotted from excessive water, we can buy new sod and place the sod. And then after sodding, the remainder of the green can be reopened for play. So this being the most expensive solution, it costs approximately $1,515 in just materials, with labor being the most expensive. So to summarize here, we've narrowed our problem down to black layer, causing our significantly low hydraulic conductivity. Our 3 solutions, minimal disturbances, is just increasing the cultural practices, aeration and top dressing. Solution 2 being just a medium disturbance, rendering the left-hand edge of the collar unplayable just while we do renovations, and a much smaller window of returning to golf. And solution 3 being the most expensive and significant disturbance with a long-term investment in future. So it's just a final cap as well. After doing all these, after picking one of these 3 solutions, it's important that you also audit your irrigation system to make sure you don't have significant overlapping, pooling, you've got the correct pressure, and make sure you're not overwatering these areas excessively. Thanks for listening, and we hope you have a good one.